Hello, good evening, and you are welcome back once again to Study Statistics with Osman Abdul Baki. I'm reading BSc Statistics at Kwame Nkrumah University of Science and Technology here in Ghana, and today is 28 January 2023. Last 2 days we talk about, or we have teachings on integration by substitution, and today we would like to talk in another level or in another angle of integration by parts. So without wasting my time, let's go straight to the question. So sometimes it's kind of difficult to know the kind of method when it comes to integration improper, and this is an improper integral. Sometimes it's kind of difficult to know the kind of method. Is it integration by substitution? Is it integration by part? Or other method that you can think of? So what most need is about the question. You need to sit down critically and ask yourself, what kind of method would I need to solve this kind of question? Although this one is quite clear that we are just we have already defined the integration by part, that this question is integration by parts, but sometimes the question will be there. You have to know the tricks in which you get to know whether this is integration by part, substitution, or what you can think of. But let's go straight to the question. Before you can able to solve integration by parts, you need to know this formula. This formula is for integration by part, that is the integral of u dv equal to u times v minus the integral of v du. This makes or allow you or helps you to solve any integral question very easy. But before you can able to solve it, you need to know what your u is. So you need to know what your u is. Come in. So you need to know what your u is, what the u represent in the equation or in the formula, and what dv also mean. What dv also mean in the question. So what dv mean, and what u also mean in the question. So that is why I have given you a tip. This one is a tip. So in every question, in every proper or improper integral question where you have to use the method of integration by parts, you have to know what u means, and u needs or must take these functions: either logarithm, the this is Lie, and the abbreviated form of Lie is the L stands for logarithm, the I stands for indices, the A stands for algebra, the T stands for trigonometry, and E stands for exponential. So from the question that they will give it to you, you must define your u. That is why I've already wrote it here. So you must define your u. Also, you must define your dv. These two are very important things that you must know, and this is one of the things that students find it difficult to differentiate when an integration by part question is given. So before then, I've already mentioned or stated it to you that you must allow your u to assign to this any form of function, either logarithm, indices, algebra, trigonometry, or exponential. So without wasting my time, let's go straight to the question. Now if you look at this question, we have x. Okay, let's start from L, which is logarithm. If you find this if you see this question, there is no logarithm, which means you cannot be a logarithm. There is no logarithm, so let's cancel logarithm out. Indices, there is no indices here. Algebra, x is an algebra. So first of all, we will let u equal to x. So that is what I have written here. So u is equal to x. That is the algebra. So, and therefore this u is equal to x, and this dv dv will be equal to ex times dx. So dv will be equal to ex times dx. So dv is equal to ex times dx, and u is equal to x. That is the simple way that you can solve this question. And when u is equal to x, you have to, or you need to differentiate u with respect to x. So this is where we have differentiated u with respect to x. So du dx is equal to 1. And remember, the differentiation of x is 1, and differentiating of every constant is 0. So x is a variable, and the differentiation of x is 1. So here dx is also the same as du. When you cross multiply to give you du is equal to dx, where dx times 1 is dx. Now, as I already mentioned here, now we have already find our dx, which is equal to du, where we have, when we equate the u to any assigned function of either logarithm, indices, algebra, trigonometry, exponential. But here it was an algebra, which is which is x. And after you find your algebra, which is u, which is equal to x, then you find the derivative of u with respect to x. Now after this, the u. No, we are solving the question based on this principle, or based on this rule. If you forgot this rule, you can't solve this question. Now let's come to dv. Now dv, we already said that dv is equal to ex times dx, because u was equal to x. Now dv is equal to ex times dx, which is this one. So this is it. dv is equal to ex times dx, and here we want to find v. So how do you find v? We apply the integrate rule, or integrate sign. So we find the integration of dv, which is equal to the integration of ex dx. So we will apply the integral sign of both sides. So if you apply the integral sign of both sides, so this is what you're going to get. So this is the applying the integral sign of both sides. So if you integrate the dv, you get v, because this integral sign will cancel d, and it will left with v. And the integration of e with the power x dx is the same function, which is e with the power x. Remember, the integral of e with the power x is equal to e with the power x. Hence v is equal to x. Hence v is equal to x. Hence v is equal to x. Now we know our u, which is equal to x, and we know our v. Which is equal to ex. It's so simple to come back to the question. Now this, we just have to insert the answers that we got. We know u, we know v, and we know du. You know du is equal to dx. So let's come down. So now substituting them in the formula, we have x. I'm sorry, I'm coming. We have u, which is equal to x, and v, which is equal to e with the power x. So here we have x. So this is the formula. We have uv minus the integral of v du. So here we know u is equal to x, and v is equal to e with the power x. So x times e with the power x minus the integral of v. And here we know the v is equal to e with the power x, and times dx, which is, and we times du, and du is equal to x. Du is equal to x. So now we have inserted them in the formula, which is this one. Now we know there is an integral sign here, so we need to find the integral of e with the power x. And the integral, this will be the same. We don't want to touch or have anything with this. So this is where we have to, or we need to solve. The integral sign of e with the power x is the same as e raised to the power x. Then we bring our constant k. So that is x times e raised to the power x minus the integral of e raised to the power x is e raised to the power x plus constant. So we are just finding the integration of this. So finding the integral of e raised to the power x dx is e raised to the power x plus k, which is the constant. And hence, this is the final solution. So therefore, the integral of x times e raised to the power x dx, which is, this is the question, is equal to x times e raised to the power x minus e raised to the power x plus k. This is the final solution. So this is the final solution that we have. So let me go back again to just summarize what I have done for question 1. So this is the integration by substitution question, where u must be equal to x, because we are assigning, in this question we are assigning u and dv, and u must be equal to either logarithm, indices, algebra, trigonometry, or expectation in every question. Here algebra was first, the x was algebra, assuming there was no algebra and we didn't find any algebra, but you know there's an we have an exponential which is raised to the power x. Hence the u should have been exponential e raised to the power x, assuming there was no algebra x, because after trig we don't have trig, but there's an exponential. But since there was an algebra before the exponential, the u would take the algebra which came before the exponential, which is x. So hence u is equal to x. Then you differentiate u, which is equal to x. Then you differentiate u with respect to x, and hence you find the u dx which is equal to 1. Then you make the x or du the subject, rather, because you make the du the subject, because you will be putting the du inside this formula. Then you have to find your v, you have to find your u, and we have already found our u to be x. You have to find your du, and du, that's where du, fortunately for us, it was just simple for us to get our u, which is du is equal to x. And hence here we have to equate the dv to the rest of the form, the question and the function. Here dv is equal to e raised to the power x. Then you find the integral of both, and then you find the integral both sides, where the d will cancel the integral to make it v, because we want to find v, where the integral sign of the integral of e raised to the power x dx. So if you find the you have the formula which states that the integral of e raised to the power x is the same function that e raised to the power x. So now v is equal to e raised to the power x. Now you come back to the formula, the formula that I have given it to you. You know, this formula is very important, because the integral by part, the integration by part, this is the formula that you'll be using each and every time if the function, or if the integral, being it improper or proper integral, states you to use integration by part, or if the question you see it as an integration by part. That is the formula that you'll be using. Hence you put all the values in the function, where x is equal to u, e raised to the power x is equal to v, minus the integral of e raised to the power x plus k. K is the constant. Thank you very much for the question 1. Now let's go to the question 2. The question 2 states that the integral of x sine x dx. So how do you solve this? The same method we use. So we make u to be equal to u, sorry, my pointer is disturbing me, sorry. Okay, now u is equal to liate, the one I already stated before, liate to logarithm, indices, algebra, trigonometry, exponential. So from this question we have u, the logarithm. We don't have any logarithm here, we don't have indices, we have algebra, which is a. The same thing, u will be equal to x. From the form, you know, this is the formula. Each and every time you need to state the formula so that it will be easy for you to make the integration. Now we know u is equal to x, yes, and dv So dv, so this we have u, and this is dv, so dv will take sine x dx. So the dv will take sine x dx. So dv will take sine x dx. So this is what I have just made it here, and this is what I have written it here. So therefore, after that you need to differentiate u with respect to x. So du dx is equal to 1. This is the question. This is the solution. So du dx is equal to 1. Then you cross multiply, where du is equal to dx. So you have already found your du. Mind you, as you are finding the values of u, v. You know, this is already an v, a v. This is also a v, and we need to find du, where you will substituting them to find the final answer for the question. So here du is equal to dx. Now we have already found our du, and we have already found our u. It's left with v. How do you find v? We apply. We already made the statement that dv is equal to sine x dx. Then you apply your integral sign. You apply your integral sign where you want to find the v as the subject. So this integral will cancel the d, and it will left with v. So this is it. And the integral of sine x is minus cos x. The integral of sine x is minus cos x. So this integral will cancel d. This is what I was trying to explain it here. So so we have v, which is equal to the integral of sine x, which is minus cos x. So you find the integral of sine x, which is minus cos x, and here is v, because the integral will cancel the d for you to get v, because here we can't find the integral, which is 0. And now we know, now we have our v, we have our du, which is equal to dx, and we have our x, we have our u, which is equal to x. Now we want to put them back into the equation. Now this is it. Now this is x, so this is u times v minus integral of v du, integral of v du. So u was equal to x, but v is minus cos x, minus the integral of v minus cos x times dx, which is u, times du, which is equal to dx. Remember, du was equal to dx, so you won't put back the x du again, but it is dx. This is where du is equal to dx. Now let's simplify it. Now x times minus cos x is minus x cos x. Here we'll bring out the minus to be positive. Now so we get cos x dx, and here the integral of cos x is sine x. So so we are finding this integral, and we will leave this one hanging, because then we have nothing to do with that. So if you are finding the integral of cos x dx, it is sine x plus k, which is the constant. That's all. So this is the final solution that we have. So minus cos x plus sine x plus k. This is the final answer. Therefore, the question given, which is the integral of x sine x dx, is equal to minus x cos x plus sine x plus k. So this is the final solution for the question 2. It's quite easy. You just have to take your time. Remember to sit down and analyze which right method should I use: integration by sign, integration by substitution, or by part. So this is the second question. Now let's go to our last question. You know, I told you it's a 3 problem solving solution and a 3 trial question. So this is the last question. The integral of x squared ln x dx. The same procedure where u is equal to limit. Remember, this is a trick, or this is a hint that you must put it in your head. This is an hint. Each and every time that you're solving an integration by substitution, what should the du take and what should the dv also take? You have to put this in mind. What should the u take and what should the dv take? Because this is the formula that you'll be using, and always you must put your formula down. So which one should the u take, and which one should the dv take? Here the trick is that, or the hint is that the u is equal to LEAT. This is an abbreviation form. This is the smartest way to the smartest way to use LEAT, which stands for logarithm, L stands for logarithm, indices, algebra, trigonometry, exponential. So when the question is given, you have to go through and see, does the question have logarithm? First of all, logarithm, that's the L that you would take. Or if the question doesn't have logarithm, indices, or algebra, or trigonometry and exponential. Here, the integral of s squared ln x dx. Remember, there is no I'm coming. All right. Now there is logarithm. You know, the ln of x, ln x is the same as log x. Ln x is the same as log x. So hence you would take the log x. Is the same as log x. Remember that ln x is equal to log x, and here we are saying that u is equal to either log first of all you must assign it to log. If there is no log, you go to indices, algebra, but here fortunately we have L, which is ln x. Ln x is the same as log x, hence u will be equal to ln x, and dv will take s squared dx. Hope you understand. Very simple for you to understand. Now let's go back. Now let's continue. After we assign u is equal to x, ln x, then we find the derivative of u with respect to x. Now du dx is equal to 1 over x. If you differentiate ln x, it's 1 over x, and if you integrate 1 over x is ln x, and here we are differentiating ln x, so the differentiation of ln x is 1 over x. Hence we cross multiply. You know, if you cross multiply here, you get x du equal to dx. And remember that we are making du the subject from our formula. We need to always make du the subject from the formula. So here, so this is the cross multiplication equation that we have, and here we are making the du the subject. So this, after making the du the subject, we have du is equal to dx over x. So this is for the u. After we assign the u to the to any possible function that we have, then we come back to dv. So now we are going to solve for dv. This dv. So dv is equal to s squared dx. Remember, after we find our u, it left with s squared and dx. So here dv is equal to s squared dx, and here too we are finding v. Remember, we are finding v, so you need to apply your integral sign in both sides. So if you apply your integral sign in both sides, this will be cancelled, and you get, so this is it. So this is what I was trying to do, and here you get v. After this is being cancelled, or this it can't work, this will be v, and the integration of s squared dx is s cubed over 3. Then you come back and put it in the function, or in the equation formula. So you come back and put it in this formula. So after you find your v, you come back and put it in this formula. So u dv is equal to is equal to uv minus integral of v du. So this is where you have to put the functions or the variable that we are getting. Now this u was equal to ln x. Remember, u was equal to ln x. So you come back and put u in the function. V is equal to s cube over 3. So this is it. So s cube over 3 times ln x, which is u times v, minus the integral of x. Minus the integral of v, which is s cube over 3 times du. Remember, du was dx over x. So this is it. Dx over x is for u. Then here the x will cancel itself 1, and it will cancel here, and remaining x squared. So here this will remain be the same. Here will remain the same. So here we'll bring the 1 over 3 out. Remember there is 1 over 3. So 1 over 3 will come out, and it will left with s squared. Remember, this x has cancelled the s cube to making it and so it's left with s squared. So the same thing as usual, you find the integration of s squared, which is s cube over 3, hence plus k. Remember, plus k, which is the constant. Hence we have the s cube over 3 ln x minus, remember, 1 over 3 times s cube over 3 is s cube over 9. Remember, 3 times 3 is 9, plus k, which is the constant. So hence this is the final solution. So this is the final solution. Hence the question given, which is the integral of s cube ln x dx, is equal to s cube over 3 ln x minus s cube plus k. So this is the final solution that we have. So thank you very much for having time with me. And this is a try work. I'm giving it to you. This is a try work. That is the integral of ln x dx, integral of s squared sine x dx, and integral of s squared ex e raised to the power x dx. Thank you very much for having time with me. We'll meet next time. In case you have any question or anything we have to discuss, you can access me, or you can message me on email, osmanabdulbaki427@gmail.com, osmanabdulbaki427@gmail.com. Thank you very much and have a wonderful day. So this is the all what you have for today.